the VPN in those videos. All
Okay.
right, no worries. So you know what is VPN. I'm not going to be denying on that part.
Yeah.
Basically, we are trying to establish a secure communication between
Mhm,
two different networks which are in a geographically
mhm.
different location, right? So the
Right.
nuances behind these things and all I have explained you in the theory, the video part and all. Okay, now there are a variety of VPNs we used to talk about site to site and remote access. This is what we typically classify. But even site to site, you have a variety of VPNs. When I say site to site, the communication is going to be established between two different VPN gateways. What I mean to say, the tunnel is going to be established between two different devices. All the traffic behind the network is going to be protected through the VPN tunnel got established between these two devices. Right? When it comes to remote access VPN, it's a kind of a mobile user, the person who wants to get connected to the network from the home or from different locations. A mobile user who wants to get connected to the corporate and then want to access the resources. That is where we take the help of remote access. But the concept behind the protection of traffic like confidentiality, integrity, and availability remains the same. But how the type of VPN is going to be working is little different. So this VPN is going to be established between two different devices, whereas here remote access, one of the end is the VPN gateway and one of the end is your endpoint, right? So a user who is using a laptop tried establishing the communication with the corporate network by establishing a tunnel to a VPN gateway. That's the key differences. We may take the help of client software. Palo Alto calls this as Global Protect, right? So Global Protect,
Mhm.
believe it or not, you have a separate training program only on this.
Only on
Only on that, which we call it as Prisma Access.
personal access.
Prisma is a high demanded training program currently in Palo Alto,
Okay.
right?
Personal.
So you might be heard about a SASE, right?
The what? Sorry.
SASE, SASE, Secure Access, Secure Edge.
No, not at the moment. No, I haven't.
Oh, okay. The combination of SD-WAN and remote access is called SASE,
Oh, okay, okay, okay.
right? So,
The SD1 solution is okay.
yeah. So, now what is that? I don't know. Now, what is that going to happen? If you're going to be talking only about remote access, that is called as Prisma Access in Palo Alto.
Mm-hmm.
If you would
Okay,
like to discuss something related to SD-WAN, there is something called Prisma SD-WAN.
personal SD1.
If you combine both of these two things together, and the solution is called as SASE.
SASA.
Secure
Okay.
access, secure edge.
Secure access, secure edge. Okay.
Right? So highly demanded, highly what do you call it as used by the customers. It's a cloud-based solution, really good actually. Anyway, so when it comes to site-to-site VPN, we have classified the VPN as point-to-point VPN, hub and spoke VPN, point to multi-point. That's what hub and spoke. Full mesh VPNs. There are so many types of VPNs are available when it comes to site to site. Basically, you have two networks, network one, network two, and you are trying to establish the connection between these two via a firewall or a router, could be anything, right? So this gateway connects to the internal network, and this gateway connects to the internal network, and you have internet. And via internet, both the gateways are connected. And then using this internet, you establish a secure tunnel between these two, is what we call it as VPN. Now, again, in this site-to-site VPN, majorly classified into two. One is called as a route-based VPN. The other one is called as policy-based VPN. So policy-based VPN is supported by a couple of vendors. Route-based VPN supported by a couple of vendors, and some of the products may support both of them also. So your Palo Alto supports route-based VPN. What I mean to say, the other name for route-based VPN is also known as always-on VPN. When it
Always
comes to
on.
policy-based VPN, it's called as on-demand VPN. Okay.
Okay.
So what I mean to say, when case of a policy-based VPN, the traffic will be received by the firewall and it looks into the policy matching. According to the policy, the tunnel is going to be the action. Only then the tunnel negotiation will happen and then the traffic will be forwarded, which may cause some additional delay into it. Whereas route-based VPN doesn't matter whether you have received the traffic for that specific destination or not. The tunnel will be up as long as you have a route pointing to the tunnel. Based on the route, the VPN is going to be chosen. Based on the policy, the VPN will be chosen. Because policy is going to be for some specific traffic, not always the tunnel needs to be available. If in case it's not available, the negotiation will start. After the negotiation, tunnel will be formed, traffic will pass through. If the tunnel doesn't have any of the traffic over a period of time, the tunnel will be cleared. Once again, the tunnel can be created if additional traffic comes in and matching the policy. That's why we are calling it as on-demand VPN. Route-based VPN, as long as you have the route, right? The VPN will be up. So when the traffic comes in, immediately the traffic received is matching that route. Immediately it will be forwarded to the tunnel, so there won't be any additional delay. Whereas policy-based VPN, it's quite possible that you can expect some delay in transmitting the traffic through the tunnel, right? So your Palo Alto VPN supports route-based VPN. There is no support for policy-based VPN. You understand what I'm saying?
Understand.
All right. Now, so when I say route-based VPN, does it mean that I don't need a policy? Of course, you need a policy. Because when the traffic passing through the interface, which are part of two different zones, then you need policy to permit it. Right or not? That is the basic architecture of your Palo Alto firewall. Right? So if the traffic is passing through the firewall, passing through between two different interfaces, which are part of two different zones, then you have to have the policy to permit it. If not, you will not be able to see the traffic. And keep in mind, this is not going to be tested in your examination of PCNSA. If you're coming to PCNSA, you will be tested. Right? You won't be having any questions on VPN when you do PCNSA examination. But still, I'm just giving you the demo just because probably you might be familiar with VPN configuration also. I'm not very sure, but this is for my satisfaction.
Okay.
All right. Now, to work with this route-based VPN, you need to have something called a tunnel interface, right? So the tunnel interface is supposed to be associated to a zone. You don't have a choice. Now, if these zones belongs to, I have the choice of associating this tunnel interface to the same zone as the other interface. Now, what happens? Now, if the traffic is passing between two interfaces of the same zone, which means what? It is intra-zone traffic. Do I need a policy? Not necessarily. It can be part of different zone. Then you need a policy. Right? See, the architecture-wise, that logic remains the same. So you need to create a tunnel interface. The tunnel interface is going to be associated to a zone. When the traffic is passing between the interfaces, the firewall will look into it, whether both the interfaces are part of the same zone or different zone. If the traffic is part of the same zone, obviously by default, according to the default intra-zone policy, it will be permitted. But if the traffic is passing between the interfaces which are part of different zones, by default it's not allowed, then obviously you need to have the policy. So normally tunnel interfaces, we create a different zone and then we will be associating the tunnel interface to the specific zone that we have created. But it is not necessary that you have to work on the same way. You have to keep in mind what? You have to have a tunnel interface. The tunnel interface is supposed to be associated to a zone. Depending on the zones between which the traffic is flowing through, you need to take a call whether you need to have a policy or the traffic can be permitted with the default policy. Then, most important thing is you need to have a route pointing to the tunnel interface to direct traffic through the tunnel. As I said, route-based VPN requires a tunnel, requires a route. Based on that, the traffic will be tunneled through. So you need to have a route. Okay, this is point number 2. And then you need to identify there is something called as proxy ID within. Of course, I have mentioned all these things in my video also. So whatever is important here for the demonstration, I'm just explaining it. So proxy ID, we also call it as interesting traffic. When I say interesting traffic, what I mean to say, see, now the firewall is connected through an interface so that we have internet connection, correct? Now my point is any traffic flowing between the network and network 2 sent through the tunnel. But it's quite possible that the same interface is going to be used for accessing the internet by the internal users. Am I right or not? This is the tunnel interface through which the network 2 is accessible. But this is a tunnel interface which is logical, which requires the physical interface to send and receive the traffic. In my case, the physical interface is nothing but the interface which is providing connectivity to the internet. So here you need to classify which traffic needs to be sent through the tunnel and which traffic can be sent to the internet without providing those encryption, integrity, and availability part of it. So that classification is what we are calling it as proxy ID. Identify the traffic which needs to be sent through the tunnel so that the protection can be given. Identify the traffic which can be sent to the internet as it is, so that the users can access the internet as well as they can access the resources available on the other network. Whenever the traffic is going to the internet, it will be sent in clear text. Or whenever the traffic is going to be sent to the other side, it will be protected according to the negotiations what you have done. So this is what proxy ID is all about. For this proxy ID only, we will be having a route pointing to the tunnel interface. So if you are very sure about these 3 things, then obviously you can complete the configuration. Now, let me draw a small diagram so that we will be able to understand. Firewall 1, firewall 2. My internal network here is 10.1.1.0/24. Let's say this is going to be 11.1.1.1. This side 20, okay, 12.12.12.2. That's IP address on the other side. 10.1.2.0/24. Okay, this is my firewall 1. This is my firewall. Okay, now I have an interface. This one connects to my internal network, and this interface connects to you're getting my point, right? So firewalls, one interface is connecting to the local network, and one of the interface, which has an IP address of 11.1.1.1, connects to my internet. Firewall 2, again, local interface has 10.1.2.0. The outside interface connecting to the internet configured with 12.12.12.2. This is our setup. Let's assume like that. I'm just going to be doing the configuration only on one end. The same way you have to do the configuration on the other end to see the tunnel to be established.